Hello and welcome to part 3 of lesson 7.4 on operations with rational expressions. Okay, I got two examples here for you, and we're going to talk about what's called complex fractions. Here's an example of what a complex fraction is with fractions, yeah? Like 1/2 minus 1/3 over 2/3 minus 4/9, right? If I ask you how to simplify this, well, you just take it one at a time, right? You'd say, well, let me start with the numerator. 1/2 minus 1/3. I can do that. If I want to combine fractions that are added or subtracted, you need a common denominator. So you'd make 2 3/6 and 1/3 2/6, right? Subtracting those would get you 1/6 in the numerator. Then you just repeat this in the denominator and combine 2/3 minus 4/9. 2/3 would be equivalent to 6/9 to make those in terms of ninths, so you could subtract them to get 6 minus 4, which is 2/9. Once you did that, now that you have those fractions combined, you can say, oh, well, that's just 1/6. Keep, change, flip, right? It's 1/6 divided by 2/9, and the way you divide fractions is keep, change, flip. So keep the 1/6, change to multiplication, flip to become 9/2, multiply across, it's 9/12, which simplifies as 3/4. And that is a complex fraction, yeah? But of course, we're doing complex fractions with variables. But if you understand that, oh, it's just the first two parts of this series, right? It's adding and subtracting fractions, and then taking that result and doing division of fractions. And I can just do, keep, change, flip, use multiplication to do that, right? So let's see an example with some variables. All right, so number 1, simplifying this expression. Now, notice that there are negative exponents written. As a reminder, what is a negative exponent? Well, if you said x to the negative 1, excuse me for yawning, sorry, x to the negative 1 is 1 over x. X to the negative 2 is 1 over x squared. This is from unit 6, right? Negative exponents, such as 4 to the negative 1 is like 1 over 4. And 4 to the negative 2 is like 1 over 16, because that's like it's 1 over 4 squared. Yeah? So, a lot of times if you have complex fractions, they might be written with negative exponents because they're a little ugly to write as fractions. But here's what it looks like. S squared minus t to the negative 2. T to the negative 2 is 1 over t squared. Yee. And then s minus t to the negative 1 is 1 over t. Yeah? All right. So what do we do here? Well, you just focus on top, and then you focus on bottom, and then you do keep, change, flip. Sorry for yawning again. I'm tired today, guys. I'm tired. Happy Monday, though. So, here's what I say. Ignore the bottom for a moment. Yeah? No bottom. Don't care about it right now. I'm going to look at the top. Yeah? Treat the top as a single fraction that you're trying to combine. We want a common denominator. So, I see a t squared here. That's implied that it's s squared over 1. That means I want t squared as a denominator. So I would take s squared and multiply it by t squared over t squared. That way I get that denominator, t squared. This might look prettier as a single fraction, s squared t squared over, right, this is over t squared, but the 1 over t squared is also over t squared, so it's minus 1. And so you can just make that a single ratio. Boom. And that, honestly, handles the numerator. The numerator is done. Okay? Now you move to the denominator. So I'm going to erase that squiggle, and now I'm going to scratch all that out. Yeah? No, don't look at that. Just look at the denominator now. S minus 1 over t. Well, just like the previous one, the denominator is t. So I need s times t over t to get that common denominator, minus 1 over t. And because they're both over t, you can just do that. You say, oh, that's both over t. And the numerator of the first fraction is st. And then the other fraction is minus 1. So then I have that one handled. And so, you know, I've just handled both of these fractions. Whoa, hello? Okay. I've handled both these fractions individually. And so I'm done with that, right? Now that they are combined into a single ratio, like one ratio divided by another ratio, you can use keep, change, flip as a way of eliminating or rearranging the fractions using multiplication. So the numerator fraction is going to stay s squared t squared minus 1 over t squared times, because this is keep, change, flip, the bottom fraction, which is this, you flip that, it becomes t over st minus 1. Okay. Now keep in mind, by the way, this is grouped, okay? Noticing this, does anything cancel? And I would say, yeah, I do notice one thing cancel. The t squared, this t times t, which is t squared, right? One of those t's cross out with each other. So this gets me s squared t squared minus 1 over t times st minus 1. Okay. And you might think, yay, we're done. That looks pretty darn simplified. And I'd say, hey, it's pretty good, but I think you could go more, right? But this one's a little tricky to see. And it comes from the s squared t squared part. You see, s squared t squared is the same as st quantity squared. Why is this notable? Well, because that means you could rewrite it as st quantity squared minus 1 over t times st minus 1. And the thing is, well, st squared minus 1, where 1 is itself a perfect square. OMG, I said, oh my goodness, that's a difference of squares, right? St squared minus 1. This factors actually as st plus 1 times st minus 1. And then this is over t times st minus 1. Ha! So there was a common factor on top and bottom. The st minus 1s cancel, and I am left with st plus 1 over t. Boom. And that is my fully simplified rational expression. Oh my gosh, look at that. Look at the journey. Woo! Woo-hoo-hoo. What a long, just joyous path. Wouldn't you agree? Okay. Alrighty, so that's one example. And honestly, if you get it, you get it. Though, if you want to see another example worked, I am going to work the second example. But honestly, if you get the first two concepts, just combine the fractions, keep, change, flip, you're done, right? But they're, I explain that like it's easy or that it's simple, but I know it takes practice because, one, we need to practice fractions, and two, it's all this variable stuff. What the heck, the x's and y's? Oh my goodness, what's going on? Don't worry, you got this. You got this, yeah? So let's start number 2 now. And the first step would be to write this obnoxious thing in terms of fractions and not negative exponents. Again, something to the negative 2 is 1 over that something squared. So x to the negative 2 is 1 over x squared. Y to the negative 2 is 1 over y squared. On the denominator, we're going to get 1 over x squared again. And then this guy, the negative, see, x and y are both raised to a -1, but not the 2. The 2 will stay in the numerator, but the x and the y come down. And then the y to the -2 is 1 over y squared again. Okay, so let's focus our attention. Forget that crazy denominator. Do not worry about him right now. Focus on the numerator, right? What does this guy need? Well, this has x squared, this has y squared, this one x squared, this one y squared. The x squared, to get a least common denominator in the numerator, well, it would need an x squared term and a y squared term. So I'm just going to multiply by that, right? I'm going to multiply the first fraction by y squared over y squared, and the second fraction by x squared over x squared. This will get me x squared y squared in the denominators, right? So in the top, you get 1 times y squared. Well, that's just y squared. And then, the denominator is x squared y squared. Like I see that, right? This and this is shared. So there's 1 times y squared here minus, from that sign right there, minus 1 times x squared. There's the x squared. Done. Fantastic. Oh my gosh. Celebrate. Yippee. We did it. I said, boo, right? And then the little confetti. Yeah, great, right? But we're not done. We will celebrate, but we're not done yet. So we got the numerator, right? Now we're going to focus on denominator. So forget the numerator now. Focus our attention on the denominator, right? What is your LCD? Well, LCD. I need an x squared. I need 2 x's. I also need a y squared here. And I also need xy. But the thing is xy is within x squared y squared. You see, because x squared y squared is just xy. It's just that twice, right? So xy is already a term within that. So there we are. If you'd like, you could read it like that, or you can do x, y, y, if that helps you, okay? So look at the first fraction. You got 1 over x squared. What are you missing? Well, you need 2 y's. You got the 2 x's. You need the 2 y's. So you multiply this one by y squared over y squared. In the middle fraction, you have xy. And you have an x, you have a y, but you need another x and another y. So you multiply by xy over xy for the middle fraction. Okay? I hope that makes sense. And then 1 over y squared, that's y. You need x squared over x squared, because that's the thing that's missing, is that x squared. I just noticed that kind of looks like a funny face, right? That's probably you right now. Just kidding. Anyway, as we're moving along, right, I've found all the things I'm multiplying here. So it's all over, right? My denominator is x squared, y squared, as noticed by this LCD right here, right? And so I've got 1 times y squared plus 2xy plus 1 times x squared. I hope those highlights kind of helped clear up that, oh my gosh, stupid iPad. I hope those highlights kind of cleared it up, yeah? These are all having x squared, y squared in the denominator, so you're just adding the tops. Y squared plus 2xy plus x squared, okay? Okay. I don't need that x out anymore. Okay. So now that I have a single fraction here and a single fraction here, fraction divided by fraction, keep, change, flip. So the first fraction, keep, and then change to multiplication, and then flip the fraction. X squared, y squared over y squared plus 2xy plus x squared. Yeah. Now notice, on top and bottom, right, these are all groups together. Those items are grouped. You do have a common factor, x squared, y squared, on top and bottom, which cross out, leaving you with y squared minus x squared over y squared plus 2xy plus x squared. Now, can you take it further? Yes. Yes. Take a look at it, see if you can finish it and factor it from here. Maybe pause for a minute or two to see if you can finish out the problem. Now resume, you say the numerator, y squared minus x squared. Hey, that's difference of squares. That's y plus x times y minus x. The denominator, a little tricky, is a perfect square trinomial, right? This is the a squared plus 2ab plus b squared pattern. So the denominator factors as y plus x squared. Or, if you'd like, when you square something, it means y plus x times y plus x. Now notice, there is a common factor y plus x on top and bottom, which eliminate each other, leaving y minus x on top, y plus x on bottom, and there's nothing more you can simplify from there. And thus, the complex fraction is simplified. Oh, look at that. Now we can party. I said, woo. I said, woo. Yeah. I got my little party hat. And I said, dee, right? The little kazoo, right? And then there's confetti, right? And then there's people, and they're dancing, and they're saying, we're dancing, we're happy. Well, he doesn't look happy. But anyway, we're having a good time, we're dancing, and we finished the problem. So that's it for this video. I hope you had a fun time. I think I did. This was actually my favorite one to do because of look at all that. Oh, it's just so beautiful. And the answers are so elegant. Look, you had something that was kind of to start with, and it gets really ugly. And then, it's so pretty at the end. So nice. Okay. So there it is. I hope this was helpful. Have fun simplifying those complex fractions on your homework and quizzes and tests. Thanks for watching, and I'll see you later.